Dear learners, welcome in the field of science and technology. Today we learn about pharmaceutical engineering in this video. What is pharmaceutical engineering? Pharmaceutical engineering is a branch of pharmaceutical technology that deals with study of industrial processes in which raw materials are changed or separated into pharmaceutical useful products such as drugs and excipients. Pharmaceutical engineering is a branch of pharmaceutical technology that deals with study of various industrial processes for development of or manufacturing of dosage form. Pharmaceutical engineering is a branch of pharmaceutical technology which deals with study of various principles involved in the unit operation during dosage form manufacturing. Simply, pharmaceutical engineering is a branch of pharmaceutical technology which deals with study of various principles involved in the unit operation during dosage form manufacturing. Dosage form manufacturing. So, manufacturing of dosage form required various process like size reduction, size separation. So, in pharmaceutical engineering, we deal with that's various unit operations used in manufacturing of dosage form. So, these are the chapters which include in pharmaceutical engineering, that is flow of fluid, size reduction, size separation, heat transfer, evaporation, distillation, drying, mixing, filtration, centrifugation, materials of pharmaceutical plant construction, corrosion and its prevention. So in first chapter we learn about what is flow of fluid. So fluid is a continuously flow. It's a state of matter, solid, liquid and gases is a state of matters. So one of the flow of fluid is one of the state of matter. Types of flow of fluid is that laminar, turbulent or transient flow. So in that chapter we learn about what is a flow of fluid, types of flow, Reynolds number, Bernoulli's theorem. So second chapter in that size reduction. Size reduction is a unit operation in which reducing of size larger into smaller ones by applying external force. Size separation, separation of size to form uniform size or to give a uniform size by passing of that drug material into sieving. It also called sieving techniques. Heat transfer, transfer of heat from higher concentration to lower concentration. Mode of heat transfer, that is conduction, convection and radiation. There have three types of mode, that is heat transfer. Evaporation, large quantity of liquid get evaporated and make a concentrated product. Distillation, distillation techniques we utilize for water purification. Flash distillation, fractional distillation. So this type of distillation techniques we utilize for that. Drying techniques used for completely removal of moisture, free from moisture, drying of granules. Distillation, drying, evaporation. Then mixing, two dissimilar particles gathered together or put together to form uniform mass is called mixing. Mixing is in that two dissimilar particles gather together, put together to form a combined substance is called mixing. So manufacturing of dosage form, the mixing process is very important. Filtration, filtration techniques used to separate out drug components. Filtration used for separation techniques. Next, centrifugation. Centrifugation is a unit operation used for separating the constituent present in dispersion with the help of centrifugal force. Filtration techniques used for water filtration or separation, two parts. After that, centrifugation is unit operation used for separating the constituent present in dispersion with the help of centrifugal force. And last chapter in that, materials of pharmaceutical plant construction, corrosion and its prevention. So corrosion have two types, dry corrosion and wet corrosion. Corrosion occurs Absence of moisture is called dry corrosion, and corrosion occurs in presence of moisture is called wet corrosion. Materials of pharmaceutical plant construction, in that various types of material used: stainless steel, aluminum, glass, plastic. This type of materials used in plant constructions. This chapter we study about that. So flow of fluid, in that, what is flow of fluid? Fluid means continuously flow. Size reduction, reducing of the size separation, separation of size, heat transfer, transfer of heat from one form to another form, means higher concentration to lower concentration. Evaporation, large quantity of get evaporated to make concentrated product. Distillation techniques used for water purification. Drying, complete removal of moisture. Mixing means two substances mixed together. Filtration, separation techniques, and centrifugation for production of bulk drug, production of biological products, biopharmaceutical analysis of drug, evaluation of suspension and emulsion, determination of molecular weight of colloids. These applications of centrifugation. Centrifugation is a unit operation used for separating the constituent present in dispersion with the help of centrifugal force. So, first chapter in that, flow of fluid. Fluid flow may be defined as the movement of substance that can easily change shape and do not stay in one form. A fluid is a substance that continuously changes under an applied shear stress. Fluid are a subclass of phases of matter, include liquid and gases. So fluid flow may be defined as the movement of substance that can easily change shape and do not stay in one form. Size reduction is a unit operation that involves the reduction of larger particle into smaller, coarse or fine particle through the external forces, resulting in the desired size and shape. The size reduction process is also known as comminution, diminution or pulverization. Various mills used in size reduction. Hammer mill work on the principle that is impact and used for almost all drugs, coarse to medium grading. Ball mill, doubling mill, this work on the principle that is impact and attrition. This mill used for soft material. Fluid energy mill, jet mill, impact and attrition, moderately hard and friable materials. Edge runner mill, crushing and shearing force for grading tough material to fine powder. End runner mill, crushing and shearing force used for fine grinding. Colloidal mill, impact, emulsification and homogenization is used. So in lab level, reducing of particle size, we utilize mortar and pestle. That lab level in pharmaceutical, that is the manufacturing of emulsion, suspension. That time we use mortar and pestle for reduction of size. But industrial scale, pharmaceutical engineering, in that study, manufacturing of those various industrial processes like size reduction, size separation, etc. So reduction of size, we industrial scale we require a mill. In lab level, mortar and pestle. So hammer mill work on the principle that is impact, and it commonly used for coarse to medium grinding of various material. Ball mill is a type of tumbling mill that uses steel balls as a grading media. It is mainly used for grinding of soft to hard material. Jet mill is a type of fluid energy mill that uses high velocity jets of gas impart energy to the particle for size reduction. It is suitable for grading and classifying various material. Colloidal mill is commonly used for emulsification of homogenization and particle size reduction of liquid like material. Commonly used for emulsification, colloidal mill. Cutting mill, it is suitable for size reduction of fibrous and tough material. Roller mill or compression mill that uses rollers to crush and grate the material. It is used for fine grinding or intermediate grading of various material. So these are the different types of mill used for size reduction. Next, size separation. Size separation is also known as sieving, sifting and screening. Size separation is a process that involves the separation of particles of desired size from the mixture of various size particles. Size separation is a separation process. We got uniform size by passing of drug material into the various sieve. So that's why it's also called sieving or sifting or screening. Size separation is the process of separation of different sizes of a particle with the help of sedimentation techniques. So size separation is also known as sieving, sifting and screening. Size separation is a process that involves the separation of particle of desired size from the various size material. So these are the various grade of powder and sieve number along with nominal aperture size as per Indian Pharmacopoeia. Grades, there are 5 types of grade powders: coarse powder, moderately coarse powder, moderately fine powder and very fine powder. There are 5 grades of powder. Coarse powder means larger size, moderately coarse, smaller size, moderately fine powder, very small, fine powder, then small, and very fine powder, then small. So sieve number 10, 22, 44, 85, 120. Nominal aperture size, sieve number 40%, nominal aperture size 40%. So these are the grades of powders and sieve number of along with nominal aperture size as per IP. You have to remember 5 types of grades of powder: coarse powder, moderately coarse powder, moderately fine powders, very fine powders. Sieve number 10, 22, 44, 85, 120. Various competitive examinations ask that grades of powders and sieve number. You have to remember also nominal aperture size and sieve number. Heat transfer. Heat. First of all, heat means heat is the form of energy that can transfer from one system to another system as a result of temperature difference. Heat transfer means is a dynamic process in which heat is transferred spontaneously from region of higher temperature to lower temperature one. Heat transfer is a dynamic process in which heat is transferred spontaneously from a region of higher temperature to lower temperature one. Heat energy is transferred from more energetic molecule to those have less energy. Heat energy is transferred from more energetic molecule to with less energetic molecule. Therefore, the substance always tends to equalize temperature if they are contact. So heat is a form of energy. Heat transfer is a dynamic process in which heat is transferred from spontaneously from a region of higher temperature to lower temperature, not lower temperature to higher temperature. It is transferred from higher temperature to lower temperature. You have to remember. Mode of heat transfer. Heat transfer have 3 modes, different modes: conduction, convection and radiation. So conduction, in that heat transfer metals. Convections, this type of heat transfer in water molecule, neighboring molecule. And radiation, heat transfer in the form of electromagnetic radiation. So there are 3 types of mode of heat transfer: conduction, convection and radiation. Conduction, metals in that heat transfer. Convections, transfer of heat in water. And also again 2 categories: convections, natural convections and forced convections. And radiation, heat transfer in the form of electromagnetic radiation. Heat transfer stop when the two medium reach the same temperature. Heat transfer is a dynamic transfer of heat from higher temperature to lower temperature. So when a heat transfer stop when the two medium reach the same temperature, equal temperature, then when heat transfer it will be stopped. Applications of heat transfer. Heat is required for drying of wet mass during production of tablet. So drying is completely removal of moisture. That condition heat is required during the production of tablet. During distillation, water purification, distillation, heat is required for convert liquid into vapor. To prepare vegetable extract by process of evaporation, heat is supplied to liquid. For crystallization of drug, supersaturation is achieved by heating saturated solution. For sterilization of pharmaceutical, dry heat is required for sterilization of glasswares and containers, while steam is required for autoclaving. First application of heat transfer: heat is required for drying, heat is required for during distillation, To prepare vegetable extract by process of evaporation, it is supplied to liquid for crystallization of drugs. Supersaturation to achieved by heating saturated solution. For sterilization of pharmaceutical, dry heat is required for sterilization of glass phase and containers, while steam is required for autoclaving. So, in this video, we will learn about what is pharmaceutical engineering. Pharmaceutical engineering is a branch of pharmaceutical technology, deals with study of various unit operation used in manufacturing of dosage form. So these are the chapters in pharmaceutical engineering, that is flow of fluid, size reduction, size separation, heat transfer, evaporation, distillation, drying, mixing, filtration, centrifugation, materials of pharmaceutical plant construction, corrosion and its preventions. Flow of fluid may be defined as movement of substance that can easily change shape and do not stay in one form to. Fluid is a substance that continuously change under an applied shear stress. Next chapter we learn about size reduction of size from larger into smaller ones by applying external force. Size separation of size to get uniform size. Heat transfer of heat. Different three modes we learn about heat transfer, that is conduction, convection and radiation. Evaporation, a large quantity of liquid get evaporated and make a concentrated product. A distillation for water purification. Drying, complete removal of moisture. Mixing, 2D similar particle mix. Filtration, separation techniques. Centrifugation, it also separation techniques. And last, materials of pharmaceutical plant construction, corrosion and its prevention. Size reduction, we learn about various types of mill used in size reduction, that is hammer mill, ball mill, fluid energy mill, edge runner mill, end runner mill, colloidal mill, and their principle and their uses. We learn about that. Size separation, we learn about what is size separation. Then grades of powders, there are 5 types of grades of powder according to Indian Pharmacopoeia. Size separation also known as sieving, sifting and screening. Size separation is a process that involves separation of particles of desired size from mixture of various size particle. Various grades of powders: coarse powder, moderately coarse powder, moderately fine powder, very fine powder. Heat transfer, it is a form of energy that can be transferred from one system to another as a result of temperature difference. Heat transfer is a dynamic process in which heat is transferred spontaneously from a region of higher temperature to lower temperature ones. Heat is energy is transferred from more energetic molecule to those with less energy. These are the mode of heat transfer: conduction, convection, radiation, natural convection, forced convection. Heat transfer can be stopped by equal temperature, same temperature. These are the applications of heat transfer. Heat is required for drying of weight mass during production of tablet. During distillation, it is required to convert liquid into vapor. To prepare vegetable extract by process of evaporation, it is supplied to the liquid. For crystallization of drug, supersaturation is achieved by heating. These are the applications of heat transfer. Thank you for your attention, for your listening. Thank you.